So something happened here, so I'm going to continue this example. So hopefully you picked up on that. But whenever I was subtracting 6 from both sides, I divided by -2, and I was graphing this guy. So I got x is greater than -1. So from -1 to infinity, this works. Okay, so any number that is greater than -1, I can plug it into this value, and this statement would be true. So think about 0. If I plug in 0, 0 is greater than -1. It's a value that's greater than -1. And then what about 7, like way out here, or 7 billion? 7 billion would be greater than -1. So then I'm also going to mark -6 with an open circle. So I'm going to try and do this. So that's from that inequality, this -6 with an open circle. And it's open because there's no bar at the bottom, so I cannot equal -6. So I'm going to see which way to shade. But if I take a look at this, I've got an operator here. So x is less than. So that means x can take on any number that is less than -6, but not equal to -6. So how we write that is -infinity. So if I read from left to right, this goes from -infinity all the way to -6. And I'm going to use an open bracket, so a parentheses, for this open circle. So parentheses are for numbers that I can't reach. So right, if I try and plug -6 into this guy, that's not a true statement. -6 is not less than -6. It's equal to it. So it's not less than -6. So then right here, I've got -infinity to -6, so union, -1 to infinity. And that is it for this. Okay? So we're going to try another one. Let's try (3 times 5 minus 2m is less than -12), or 1/3 of 15m minus 9 is less than or equal to -3. Okay, so we're going to do both of these. So I'm going to start with the left one first. So I want to get rid of this stuff. So there's two ways I can do that. You can either distribute the 3, but I'm actually going to get rid of it. So anytime you look at a 3 in front of a parentheses or a number in front of the parentheses, that's multiplication. So even though it's distributing, it is multiplication. So to undo multiplication, you can divide both sides by 3. So I'm going to do that. So I get parentheses 5 minus 2m is less than -4. And if you take a look here, I've got 5 minus 2m, which is now no longer in parentheses because there's no distribution there. So 5 minus 2m is less than -4. So I can start to combine like terms and collect like terms on one side of the inequality. So this acts like an equal sign. So I can subtract 5 from both sides of this guy. I get -2m is less than -9. And then I get m. I'm going to divide both sides by -2. And remember, when you divide both sides by a negative, the inequality flips. So you've got m is now greater than, so I can make a g out of that. So we flip the inequality, flip the direction. Then negative divided by a negative is positive, so 9/2. Okay? So that is 9/2. And we're done with that one, so now we're going to work on this guy. So if you take a look here, they're asking us, again, they've got distributive property involved here. So you can either distribute that 1/3 or you can get rid of it. And we're actually going to get rid of it. We're going to multiply both sides by 3. So 3 times 1/3, 3/1 is the reciprocal. So that's where I got the 3 from, especially from that denominator. 3/1 times 1/3. These values will cancel. Okay, so I'm left with 1/1, which is just 1. So I've got 15m minus 9 is less than or equal to -9. And so what I want to do is solve for m. And I'm going to get rid of this -9 by adding 9 to both sides of the inequality. So once I add 9 to both sides of the inequality, these two things cancel. And I'm left with 15m is less than or equal to 0. So since 15m is less than or equal to 0, you might be confused on what to do with the 15, but think about it. So right here I've got 15 times m. So how do I undo multiplication? Well, The opposite of multiplication is division. So I divide both sides by 15, and I get m is less than or equal to 0 divided by 15, which is 0. Okay? So I've got 2 values here. I don't know why I did that. That was dyslexic. Sorry, I think I have dyslexia. I'm not just saying that. I think I actually do. So at 0, I'm going to mark 0 with a solid dot. And that's what this means, right? It's m is less than or equal to 0 means that m can be 0 and m can be any value that's less than it. And if you're wondering how I'm reading this as less than, well, if you take a look at this operator, I can make an L out of it. So less than, and over here I can make a G out of this one. So this is 9 over 2, so m is greater than 9 over 2. So I've got two statements here. I've got m is greater than 9 over 2 or m is less than or equal to 0. So, m is less than or equal to 0. So I'm looking for values that are less than 0. So values that are less than 0 are to the left. So those are the values that are lower than 0. And then over here at 9 over 2, that's about 4.5. So if you're confused on how to get that, use your graphing calculator. So if I use my graphing calculator, which is frozen up at this point, and it will not work. Okay, sorry about that. 9 over 2, use a graphing calculator if you're kind of confused on how to get the decimal for that, but it's 4.5. Okay, so at 4.5, I'm going to put an open circle because it's strictly greater than. There's no bar at the bottom, so I use an open circle and open parentheses or parentheses to mark that, and then I shade right. Okay. So I shade to the right, and I get 4.5 to infinity. So I've got two intervals here. I've got negative infinity, and if I read from left to right, negative infinity, that's where this arrow points to, all the way to 0. So any number from negative infinity to 0 works for this inequality. So m can be any value less than or equal to 0. And m can be any value from 9 over 2 with the closed parentheses, so 9 over 2 to infinity. And that's it. That's all you do for that one. So hopefully that helps. And I think I might have to kind of splice these or come back and redo some of those, but OBS cut off when I was trying to work through some of these, so I kind of lost some of the footage. But that's at least one OR example. So I've done quite a few now. 1, 2, 3. I'll do one more for good measure. This one I'll do negative 3y plus 8 is less than or equal to negative 7, or 10y minus 3 is less than or equal to negative 33. Well, I'm going to subtract 8 from both sides of this first inequality, so I get negative 3y is less than or equal to, well, negative 7 minus 8 is negative 15. And then if you take a look, I've got a negative 3 in front of this y that's being multiplied. So how do I undo multiplication? Well, I'm going to divide. So if I divide both sides by negative 3, this inequality flips, so don't forget about that, but I've got y is greater than or equal to positive 5. Or, right, I can come over here and solve this inequality. So I add 3 to both sides, and I get 10y is less than or equal to negative 30, and I divide both sides by 10. Now this inequality will not flip here, even though I have a negative on the right-hand side, I divided by a positive. So if you divide or multiply by a positive to get to your answer, you do not flip the inequality. Only when you divide or multiply by a negative. So I'm going to keep mentioning that. So I've got y is less than or equal to negative 3. I'm going to draw my number line here, and then we're going to find the solution set for y. So y can be greater than or equal to 5, or y can be less than or equal to negative 3. So I'm going to start with negative 3. So anytime it's less than or equal to, you're going to use a solid dot, or greater than or equal to. So I'm going to mark negative 3 with a solid dot. And then I'm going to look for numbers that are less than. And if you're wondering why it's less than, you can make an L out of that operator. So that's not like a mathematical reason why it says less than. It's just a good way to remember which one is less than or greater than. So I've got some kids that they kind of struggle to understand which one's less than or which one's greater than. If you can make an L out of it, it's less than. If you can make a G out of it, it's greater than. And so less than negative 3, I shade to the left. So those, right, negative 4, negative 5, negative 6, all these numbers that are lower than negative 3 are less than negative 3. And then I mark positive 5 because it's over here and it's solid, right? There's an equal to symbol, so I can have 5 inside the solution set. And then numbers that are greater than 5, that should be a 6. Numbers that are greater than 5 are 6, 7, all the way to infinity. Okay, so I've got my graph finished. I just have to do my interval notation. So if I read this from left to right, this arrow is pointing toward negative infinity. So this is negative infinity, all the way from negative infinity to negative 3. Bracket. So that means any number from negative infinity to negative 3, including negative 3, will work. And then I'm going to put a U, and then close bracket for 5. So all this stuff in between, right? Negative 1 works for neither, 0 works for neither, 1 works for neither. So these numbers that I'm skipping, they're not greater than or equal to 5, and they're not less than or equal to negative 3. So they will not work in the solution set. So that's why we're skipping them. And then we pick it up back at 5, and this arrow points all the way to infinity. So 5 to infinity. And that's it. That's it for that one. So now we're going to move on to some and problems. So with and inequalities, you are looking for overlap. So you're looking for what these two sets have in common. And if they don't both include a number, you cannot include a number in the whole set. So hopefully you'll pick up. But if I take a look up here, if I had an and between any one of these problems up here, since they skip values, notice that the arrows are always pointing the opposite direction. If I get a situation like this with an and problem, then there's no solution. It's because they have to fit both statements. So the only statements that would fit both would be in between the graphs, whatever the graphs have in common. So all of these, if they had and in between, they would be no solution. Okay, so my first and problem is 2x plus 3 is greater than negative 9, and 8x minus 2 is less than 30. So you want to solve both just like an OR problem and then graph it and then see where the overlap is. And we'll use an intersection to denote the overlap of the region. So what I've got here is 2x plus 3 is greater than negative 9. So I can subtract 3 from both sides, so I get 2x is greater than negative 12. So since 2x is greater than negative 12, I can divide both sides by 2, and I get x is greater than negative 6. And over here, I've got 8x minus 2 is less than 0. So if I add 2 to both sides of this inequality, I get 8x is less than 2, which means x is less than 2 over 8, and this fraction can be reduced. Divide top and bottom by 2. Since they're both divisible by 2, I can reduce this to 1/4. So I've got two values. I've got -6. I'm going to draw on this number line. And I think that'll be good. So I'm going to mark -6, and it's going to be an open circle. And this is telling me to shade right. Okay, so any number that's greater than -6, and it has to be less than 1/4. So 1/4 is actually 0.25 as a fraction. I mean as a decimal, not as a fraction. 1/4, 0.25. So I'm going to mark it, and its x is less than, greater. So 0.25 here, and it's the numbers that are less than 0.25 shade to the left. Okay? So from -6 to 0.25, that is the overlap. So even though for this other inequality, I know that -7 and -6 itself is less than 1/4, but it has to include both. So if you take a look here, and this is still a little bit confusing, I'm going to just draw the two and draw between. Now this doesn't always work, but in this case it does because they have an overlap. If they don't have an overlap, don't do that. But that overlap is where they work. And if this was solid up here, then I'd have a solid dot down here. So if they're both solid, or there's a line here and there's a solid dot here, same thing with this endpoint. If this is solid and there's a line continuing that direction, then this would be solid. So they have to include both numbers, but this tells me I can have any number from -6, not including -6, so close to -6, like -5.99, that would work, all the way to 1/4. I'm going to leave that as a fraction, so that's just best practice. You can do, I think you can do 0.25, but a lot of tests will use fractions because people are uncomfortable with it. So all the way to 1/4, and that's a little over, so I'm sorry about that. It's more like a half. Let me fix that. Kind of OCD about that kind of thing. So right there. Parentheses. So that is the overlap. So we'll do one more and problem and I'll call it a day because this is a pretty long video at this point. 2w plus 1 is less than or equal to 11. No, I don't want to do this one. I'm going to do a harder one. Oh, yeah. Oftentimes you'll see them like this. And so you might be a little confused and you might say, I'm going to change that letter, just use X. You might be a little confused and you might say, okay, well, what do I do whenever there's two operators? Well, there's two ways you can solve this, but I'm going to make sure that I split it up into two terms. So what this says is 4 is less than 3x plus 4, and 3x plus 4 is less than 19. So that gives you your two values. Okay, so what I can do is I can subtract 4 from both sides of this guy, and I get 0 is less than 3x. If I divide both sides by 3, I get 0 is less than x, which is the same thing as saying x is greater than 0. Okay? So x is bigger than 0. And then over here, I'm going to subtract 4 from both sides. So I get 3x is less than 15. And so x is less than 5. So if I divide both sides by 3, there's no inequality flip, so we're good there. And so I'm going to mark both of these values. So I've got 0. I've got 5. So for the first inequality, I've got x is greater than 0. So if I mark 0, I can shade anything to the right. These are all the values that are greater than 0. And then if I take a look at x is less than 5, I can take that guy. So that is 5, but it's not inclusive. So neither one of these get an a closed dot because they don't have a bar at the bottom. And I can shade to the left because those are numbers that are less than 5. So x can be close to 5 from the left and then be any number less than 5. So I've got x can take on any number from 0 to 5. So if you take a look there, they don't have 5 in common. They don't have 0 in common, but every other number between they have it. So this is a open parentheses, 0 to 5, open parentheses. And so you can plug in any value between 0 and 5 and it would work for both. So like 1. So here's an example. So if I plug in 1 into both these inequalities, 1 is both greater than 0. It's between 0 and 5, so 1 is both greater than 0 and 1 is also less than 5. And then a 2 is another value. So 2 is both greater than 0 and 2 is less than 5. So that works. And then you can pick some really ridiculous numbers like 2.6752. That's also between the 0 and 5. So 2.6752 is greater than 0 and 2.6752 is also less than 5. So any number between those. That's what this set means. Any number between 0 and 5, not including 0 and 5. Because that would make the inequality not true if you included 0 and 5. 0 cannot be greater than 0. 5 cannot be less than itself. So the only way that would work is if there was a bar at the bottom. Then it would say 5 can be less than or equal to 5. That would be true. So that's all I've got. So I hope this video helps. And again, I'm going to come up here. I lost some of the work that I did, so make sure to solve OR inequalities. You want to solve each inequality individually first, then graph. So here's one example. And if you need me to explain that, just make a comment and I'll do another one. But I subtracted 4 from both sides of the first inequality, divided by 3. The inequality didn't flip because I didn't divide by a negative. X is less than or equal to 2. And then the other one, I divided both sides by 5. X is greater than 9. So there's my set. And then this one is what I did after that. So you can take a look at those if you want to, try them out. And if you need me to post that other video, I can, but OBS crashed. So you guys take it easy.